Hi friend, last video we have discussed the interval timer. Now in this video we discuss the simultaneous channel operation function. This simultaneous operation function, why this is simultaneous? Because it's a combination of the master channel and a slave channel. Okay, now for the more understanding, see the one shot pulse output. This one-shot pulse output is having a channel N master and channel P is a slave. This is a input, timer input, and it generates the master, generates the interrupt, and on the pin on any timer output it is given. Okay, if you see here, timer master, it start here and giving the small output timing and set it from set the master, give the pulse width, and after completion slave reset. Okay, second one is a PWM. As you can see, the PWM also got one master and one slave. One is for setting the duty cycle, and another is the multiple PWM. Also same multiple PWM, it supports a multiple slaves for one master and multiple slaves interrupt generated on this duty. For this you can see in simultaneous channel operation function of unit 619, you can see the some operation they have done. Same, this one is a block diagram of the one short pulse input. This is the input section. This goes in the edge detection, then trigger it section, and in TS, MN and edge detection goes in the trigger section, and it comes to the counter, timer counter register, and this is the data where we have selected time given time. This is an operation called clock CKM1 and CKM0. It comes to the interrupt controller and it gives the interrupt, and it comes to the output pin, this one. Same like a PWM. This is an operation as a PWM function. Two channel can be used to set the pulse at any time duty cycle. Okay, this is a formula of the pulse period, duty period, 0% output and 100% output. Okay, refer this manual for your more detail. Now let's see in the software side. Then CubeSort, let's create any project. I already know. Now we'll directly see the timer. In last example we have done the interval timer. Now for the PWM, if suppose channel 1 is, you see interval input and delay, this one shot, this is not available supported to the channel 1. This channel 2 is support to PWM. Suppose I have set the PWM master, so I'll select a PWM master, automatically the PWM slave is selected. Now suppose in channel 2, here if you see channel 2 is having the master and channel 3 is a slave. Here we need to set our frequency. As you know, frequency is inversely proportional to the time. This is 100 microsecond, suppose here 100 microsecond time is set. So if you see the calculator, means how much in microsecond, and here it is going for the wait for the time. Okay, so in hertz, if you see it is in hertz, kilohertz, it is 10 kilohertz for the 100 microsecond. It's a 10 kilohertz. Okay, and duty cycle, this slave you can set the duty cycle. This is the output setting. Initial output value is 0 and output level set to high, and this one means 0 to high. Okay, and this master, this is having the interrupt setting, interrupt low, and slave is also having the interrupt. Okay, just generate a protocol. So again comes in the interrupt section. Yes, because this one the last example is the same in that, the same in the create, timer create, and going down, this is timer interval already set at previous one, and now the another section is added here, channel to the PWM master and PWM slave. Okay, and this output pin is set for the P3. Okay, PM3, and if you go in the port section, PM3 port 3, this port 1 is set for the output pin. So if you are trying to set, so it will show this pin is already set and this is connecting to other pin. Okay, so now comes in the .c file, timer.c. So to start the PWM, you need to call this channel. Okay, so first let's understand which port is set for the master and which for the slave. Okay, this is a reflecting pin. If suppose here your pin is not reflecting or not showing anything, so the reflect in pin. Afterwards, see the top view. So this is a 20 reset register and timer. Okay, so this one is a timer P31 or timer 003 is set for the output. Okay, so I need to check the P003, port number is 31. Okay, and here timer.c, user.c, here is the interrupt for PWM, then master and slave. So we have started here channel of the master for the channel. Okay, now build it. Again we are checking it in the simulator, then build and download. Then your GUI window will open. Now you can see, or we'll see if this is in GUI window, whether our PWM waveform is generated or not. Take a new one. So we have to see the timer chart. Okay, then here just right click, select a pin, which pin we want to see, port 31, correct, this timer, then okay, and then start the function. Okay, now here you can see our PWM is generating. It is too much faster, so make it low. Switch off it again, x. Okay, its divide means is going to come. Okay, now see, now we are able to see the perfectly. Okay, this is a PWM. Okay, so our PWM 50% duty cycle is going to perfectly correct. Okay, now suppose I don't want to 50%, I want to 30 or 70%. So go in your timer file, then here suppose I want 70%. Okay, so first 70%, first one and last one 30%. Okay, 70, 30, 100. Then again build it, and download. Now not download, now download it. Now this is my last one. Okay, so start it. So stop. Now let's observe here my first 70% and this my 30%. 70% is on, 30% is off. Is it PW 50% on, 50% on? So now this 70% is on, 30% is off. Okay, I hope it is clear to you. If any query, thanks for watching this video.